Hi, my name is Sundari Vorganti, and I'm going to show you how InfoSphere Guardium can help address the challenge of data security and compliance in Hadoop. The big data opportunity is all about extracting new insights that can help improve decision-making processes. Massive volume, variety, and velocity are defining characteristics of big data. However, lack of security controls can prevent a rollout of Hadoop in enterprise environments. For example, a mix of data sensitivities makes it difficult to enforce correct privacy controls or other compliance mandates. Aggregating large amounts of data within Hadoop can increase the risk of a data breach. Organizations that cannot take these risks will silo their big data, thereby limiting its opportunity. InfoSphere Guardium can help address some of these challenges. Let's see how it works. Guardium uses an unobtrusive, lightweight software probe called an SDAP to monitor activity throughout the Hadoop stack. Messages related to data activity are copied and sent to a hardened appliance called the collector. This architecture has minimal impact on the network and does not require any configuration changes on the server and forces separation of duties. The collector stores the messages into its internal database, which can trigger alerts and generate compliance reports that can be fed into an automated workflow system for sign-offs. Hadoop operations flow through different components in the Hadoop stack. If you only monitor file system access from the file system logs, you can't always tell which user or application originated the activity. It's like showing disk segment I/O operations instead of an audit trail of a database. Guardium can help you make sense of this activity by reporting on who submitted the query, what jobs are running on the Hadoop system, are they authorized, and how are these jobs executed, what files or tables are accessed. Okay. Now let's dig a little deeper into the configuration. Monitoring requires that Guardium SDAPs be installed on key nodes in the system, such as the name node and the Hive server. By the way, Guardium has a proven history in enterprise deployments and includes centralized installation and update for SDAPs and a robust API for creating automation scripts. The last part of configuration is to deploy Guardium policies. Hadoop clusters generate a lot of activity that is not required for auditing, such as health checking, and that can make it difficult to discern important auditable events. Guardium provides a pre-built customizable policy you can use to filter out this noise. Other configurable policies can help with audit and compliance requirements. Okay, now let's take a look at how a Hive query is processed in Hadoop. Hive provides an SQL-like query interface to Hadoop data. Here is how the request is processed by Hadoop. When a query is submitted in Hue Beeswax user interface, Hive uses the MapReduce framework to execute the query. The MapReduce framework reads from and writes to the Hadoop file system. And now, let's see how Guardium reports on the query processing I just described. First, we'll look at the UI level. In this example, I'm doing a select count query through the Hue Beeswax client to count the number of page clicks I have. And you can see the Guardium report includes the select count command and my user ID. As I mentioned before, underneath the covers, the Hive interface uses the MapReduce framework to run the query. In the Cloudera UI, you can see the job ID and my user ID for the MapReduce job. And in the Guardium report, you can see the full message details, including the job number and my ID. When it comes down to reading and writing data, we can see the actual file access at the file system level. Here's what the file system access looks like from the Cloudera UI. And the Guardium report includes the username and the file commands used to access the underlying data. Now let's look at another monitoring example, this time using the IBM InfoSphere Big Insights. Assume I want to run an application that does some analysis of credit card ownership data. First, I use the Big Insights web console to submit the job, which uses the MapReduce framework. And the Big Insights console shows me the workflow program called Uzi has scheduled the job. The MapReduce framework writes to and reads from the Hadoop file system. The Guardium Big Insights report shows detailed messages with the user group and the file permissions, as well as breaking out relevant columns for reporting and alerting. Let's look at a few of the reports provided specifically for Hadoop monitoring. Here's one that can help you find unauthorized MapReduce jobs, which gives you the job name and user information. You can then determine whether this job needs to be added to an authorized group or otherwise requires further investigation. Guardium includes sensitive data alerts on Incident Management Report, which can help you determine who is trying to access your sensitive data. You can optionally have alerts sent to email as well. Let's review the InfoSphere Guardium solution for Hadoop activity monitoring. You have seen how offloading of audit data to a separate hardened appliance can enforce separation of duties. Built-in policies and reports can help reduce noise and help you meet your auditing challenges quickly. You've seen detailed activity messages as well as an example of how alerting can be implemented. The full power of Guardium workflow for managing sign-offs helps relieve the administrative burden of compliance. Guardium monitoring integrates with the existing enterprise security intelligence and event monitoring systems. Guardium monitors a wide range of other enterprise databases, warehouses, file shares, and more. For more details, read the article on IBM Developer Works or visit ibm.com/Guardium.